KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Next example 41. An Apache helicopter of enemy is flying along the curve given by y is equal to x square plus 7. A soldier is placed at a point 3, 7. Okay, he wants to shoot down the helicopter when it is nearest to him. Find the nearest distance. Find the nearest distance. What is given here is an Apache helicopter of enemy is flying along the curve y is equal to x square plus 7. Y is equal to x square plus 7. It is upward parabola. Okay, upward parabola having vertex at 0, 7. Having vertex at 0, 7. Okay. Now a soldier is placed at the point 3, 7. At the point 3, 7. At the point 3, 7. Okay. He wants to shoot down the helicopter when it is nearest to him. It is easy to shoot it down when it is close to him. Okay. Now it can be any point on the curve y is equal to x square plus 7. Y is equal to x square plus 7, that is upward parabola. Now soldier is at a point 3, 7. Now we have to find a point on the parabola which is close to him. Have to find a point on the parabola which is close to him. Okay, we have to find a point on the parabola y is equal to x square plus 7 which is close to the soldier who is standing at the point 3, 7. Okay, now he is standing at the point 3, 7. Now any point on the parabola, what we can consider? Now y is equal to x square plus 7. Y is equal to x square plus 7. So x ordinate is x means y ordinate is what? X square plus 7. So for each value of x, the helicopter position is at the point ordered pair x, x square plus 7. Ordered pair x, x square plus 7. Ordered pair x, x square plus 7. Okay. Now distance between soldier and this point. D is equal to what? D is equal to distance between ordered pair 3, 7 and ordered pair x, x square plus 7. This distance square root of x minus 3 whole square plus x square minus 7 whole square. Okay, so here minus 7 plus 7 cancel. So x square whole square is what? X power 4 plus x minus 3 whole square. So distance is equal to what? Distance is square root of x minus 3 whole square plus x power 4. Distance is equal to D is equal to square root of x minus 3 whole square plus x power 4. Now we have to minimize this quantity. We have to minimize this quantity. Minimum distance. Distance we have to minimize. So minimum of this quantity is nothing but if inside quantity is minimum. Suppose inside the square root quantity is minimum, then obviously D is minimum. Okay. When inside the square root quantity is minimum, so square root of that minimum value is again minimum. So I'll consider the inside the square root as f of x. Let f of x equal to x minus 3 whole square plus x power 4. Okay. Now I'll minimize f of x. So for minimum or maximum, first find first derivative equal to 0. Equal to 0. So f of x f of x equal to what? Let f of x is x minus 3 whole square plus x power 4. Okay, now f dash of x, derivative of this part, x minus 3 whole square derivative is what? 2 into x minus 3 plus x power 4 derivative 4 into x cube. 4 into x cube. Okay, so what we have? 4x cube plus 2x minus 6. Okay, what we have here? What we have? 2x minus 6 plus 4x cube. Now if sum of quotients is 0, then x equal to 1 is one of the factor. So if we factorize, what we will get? It is 2 into x minus 1 into 2x square plus 2x plus 3. Okay, we will get like this. Now for minimum or maximum, find f dash of x and equate to 0. Okay, now f dash of x equal to 0 means 2 into x minus 1 into 2x square plus 2x plus 3 equal to 0. So 2 is non-zero. So then x minus 1 equal to 0 or 2x square plus 2x plus 3 equal to 0. So x minus 1 equal to 0 means what? X equal to 1. X equal to 1 or 2x square plus 2x plus 3 equal to 0. This quadratic equation has no real roots. Now how we can say quadratic equation is having no real roots? If b square minus 4ac, if discriminant is negative, such quadratic equation does not have any real roots. Now here b square minus 4ac, now here ax square plus bx plus c equal to 0. If you compare with ax square plus bx plus c equal to 0, a value 2, b value 2, c value 3. Okay, b square, 2 square is what? 4, minus 4 into 2 into 3, negative. 4 minus 4 into 2 into 3 is negative. So discriminant negative means no real root. So for this quadratic equation, no real root. Okay, so only one real root we have here, that is x equal to 1. Okay, so there is only one critical point, that is x is equal to 1. So x is equal to 1. So at this critical point we have to find function value. So f of 1. So f of 1 is equal to how much? F of 1 is 1 minus 3 whole square plus 1 power 4. Okay. Now 1 minus 3 is what? Minus 2 square is 4, 4 plus 1 is 5. So f of 1 is equal to how much? 5. So d is equal to how much? D is square root of f of x, no? So d is square root of f of x. Okay, so d is how much? Square root of f of 1, nothing but square root of 5. So the distance between soldier and helicopter is what? Square root of 5 when x is equal to 1. When x equal to 1, this is the distance. How much it is? Root 5. Okay. Now this root 5 is either maximum or minimum. Root 5 is either maximum or minimum. Okay, f dash of x equal to 0. F dash of x equal to 0 at a point. Okay, so at that point we will find function value that may be minimum or that may be maximum also. Okay, that may be minimum or that may be maximum. So root 5 may be minimum value or may be maximum value. So how we can say that is a minimum value or maximum value? Okay, now f of 1 we got it as 5, distance we got it as root 5. Okay, you find any other value, f of 0, f of 1, f of 2, f of 3. If among all these values, suppose root 5 is greatest value, then that is the maximum. Suppose f of 0, f of 2, f of 3, f of 4, among all these values, root 5 is minimum, then root 5 is the least value. Now find out f of 0. For example, f of 0 is how much? 0 minus 3 whole square plus 0 square. 0 minus 3 square is what? 9. Okay, so f of 3 is 9. So d is equal to square root of f of 3, square root of f of 0, square root of f of 0 is how much? Square root of f of 0 is how much? 3. 3 is greater than root 5, no? 3 is greater than root 5. So root 5 is minimum value of root of f of x. Root 5 is the minimum value of root of f of x. Root 5 is the minimum value of root of f of x, nothing but minimum distance. Minimum distance is how much? Minimum distance is square root of 5. Square root of 5 is the minimum distance between the soldier and the helicopter. So at what point? When x equal to 1. X equal to 1 means 1 comma 8. Okay, when the helicopter is at the point 1 comma 8, soldier who is standing at 3 comma 7, he can shoot more easily. So nearest distance between the soldier and helicopter is root 5, okay, at the point when helicopter is at the point ordered pair 1 comma 8, okay, that is the answer. So minimum distance between the soldier and helicopter is how much? Square root of 5. So what we did here, a soldier is standing at 3 comma 7, okay, and any point on the parabola we can consider as x square plus 7. So distance formula we applied. So what we got, distance is equal to square root of x minus 3 whole square plus x power 4. Okay. Now we have to minimize the distance. We have to minimize the distance. So this is distance is minimum when inside the square root quantity is minimum. I'll consider the value inside the square root as f of x. Let f of x equal to x minus 3 whole square plus x power 4. Okay, f dash of x equal to 0. So we got f dash of x equal to 0 at x is equal to 1. So f of 1 is root 5. So distance between the soldier and helicopter is how much? Square root of f of 1, nothing but root 5. So this root 5 may be maximum value, may be minimum value. Okay, it may be either minimum or maximum value. So for this we will calculate any other point, f of 2, f of 3, something you calculate. So f of 0, if you calculate f of square root of f of 0, how much we got? 3, that is greater than square root of 5. Okay, not only at 0, you can verify at any point. Okay, that value will be more than root 5. Okay. So what we know, root 5 is the minimum value of square root of f of x. So root 5 is the minimum distance between the soldier and helicopter. So minimum distance exists at the point 1 comma 8. When helicopter is at an ordered pair 1 comma 8, distance between helicopter and soldier standing at 3 comma 7 is square root of 5. That is the minimum distance. Okay. Now with this we completed example problems. Next we'll start exercise 6.5. Exercise 6.5. First question, find the maximum and minimum values, if any, of the following functions given by first one. F of x equal to 2x minus 1 whole square plus 3. 2x minus 1 whole square plus 3. Okay. Find maximum and minimum values, if any. If exist, we have to find. So first question, what is the function? 2x minus 1 whole square plus 3. Okay. If you observe, this is upward parabola, like in example 41, this is also upward parabola having 2x minus 1 whole square plus 3. Okay, this is upward parabola. Okay, at x equal to 1 by 3, at x equal to 1 by 2, this part is 0, 3. So 1 by 2 comma 3 is the vertex. So upward parabola, so minimum exists at the point x equal to 1 by 2 and minimum value is 3. So no maximum value, because upward parabola as x increases or x decreases, y value increases because of square. Okay, that is what we will write here. So what is minimum value? Minimum value is 3 when x is equal to 1 by 2. Minimum value exists at x is equal to 1 by 2 and minimum value is 3. Okay, so that is what we'll write here. So what we have, function f of x equal to 2x minus 1 whole square plus 3. Okay, what we know, square of a function, square is always positive, greater than or equal to 0. So it can be observed that 2x minus 1 whole square is greater than or equal to 0 for every real number. Okay, 2x minus 1 whole square greater than or equal to 0 for every real number. So if we add 3 on both sides, 2x minus 1 whole square plus 3 is always greater than or equal to 3. So 2x minus 1 whole square plus 3 always greater than or equal to 3 for every real number. Now 2x minus 1 whole square plus 3 is nothing but f of x. No? So f of x is always greater than or equal to 3. F of x is always greater than or equal to 3. So f of x is always greater than or equal to 3, greater than or equal to 3. So means f of x has a minimum value 3. Minimum value 3. When we have minimum value, when this part is 0, no? So minimum value of f is attained when 2x minus 1 whole square equal to 0. Nothing but 2x minus 1 equal to 0 means x is equal to 1 by 2. Okay. So at x equal to 1 by 2, minimum value exists, and the minimum value of f is equal to f of 1 by 2 is equal to 2 into 1 by 2 whole square minus 2 into 1 by 2 minus 1 whole square plus 3. 2 cancel, 1 minus 1 is 0, so 3. Okay, so for any value of x, f of x will always be greater than or equal to 3. Hence the function does not have a particular maximum value. Okay, only minimum value exists. Minimum value is 3 and minimum value exists at x is equal to 1 by 2. Okay, for this function f of x has a minimum value is 3, exists at the point x is equal to 1 by 2. Okay, and no maximum because it is upward parabola. As x value increases or x value decreases, 2x minus 1 whole square always increases, plus 3 is also increases. So f of x increases as x increases, or f of x increases as x decreases. Okay, f of x approaches to infinity as x approaches to infinity, f of x approaches to infinity as x approaches to minus infinity also. Okay, no maximum and minimum exists. Minimum value is 3 and minimum value exists at x is equal to 1 by 2. Okay, next question, f of x equal to 9x square plus 12x plus 2. F of x equal to 9x square plus 12x plus 2. Okay, for this function there is minimum or maximum or both we have to find. Okay, now 9x square plus 12x plus 2, I'll write like this, 9x square plus 12x plus 4 minus 2, adding 2 and minus 2, adding 2 and minus 2. Now first 3 terms if we consider, 9x square we can write as 3x whole square plus 2 into 3x into 2 plus 2 square minus 2. So first 3 terms what we can write, 3x plus 2 whole square we can write. So 3x plus 2 whole square minus 2, 3x plus 2 whole square minus 2. What is f of x? 3x plus 2 whole square minus 2. F of x equal to 3x plus 2 whole square minus 2. This is f of x. Okay, like previous problem, 3x plus 2 whole square of a number is always greater than or equal to 0. So 3x plus 2 whole square is always greater than or equal to 0 for every real number. So 3x plus 2 whole square always greater than or equal to 0 for every real number. I'll add minus 2 on both sides. 3x plus 2 whole square minus 2 greater than or equal to 0 minus 2 for every real number. So 3x plus 2 whole square minus 2 is always greater than or equal to minus 2 for every real number. Okay, means f of x is always greater than minus 2 for every real number. F of x is greater than or equal to minus 2. F of x is greater than or equal to minus 2 means f of x is minimum value is how much? Minus 2. And minimum value exists when 3x plus 2 is 0. So minimum value of f is attained when 3x plus 2 is 0. Okay, 3x plus 2 is 0 means x is equal to minus 2 by 3. So this function has a minimum value minus 2 when x is equal to minus 2 by 3. Okay, this is also upward parabola only. Upward parabola having vertex at minus 2 by 3 comma minus 2. So minimum value exists at the point x is equal to minus 2 by 3 and minimum value is minus 2. Okay, that is what it is written here. The minimum value of f is attained when x is equal to minus 2 by 3. So f of minus 2 by 3 if you calculate what will get? Minus 2. Okay, for any value of x, f of x is always greater than or equal to minus 2. Hence function f does not have a particular maximum value. But first question or second question both are upward parabolas. Upward parabolas means vertex will be their minimum. Okay, so here in this question minimum exists at minus 2 by 3 at x equal to minus 2 by 3 and minimum value is minus 2. Maximum does not exist because it is upward parabola. As x value approaches to infinity, f of x approaches to infinity. As x value approaches to minus infinity, then also f of x approaches to infinity. Okay, so here in both the cases minimum value exists and maximum value does not exist, because upward parabola means minimum value exists and maximum value does not exist. Downward parabola, if it is a downward parabola, maximum value exists and minimum value does not exist. Okay, now for this problem maximum value does not exist. Minimum value exists, and minimum value exists at the point x is equal to minus 2 by 3, and minimum value is minus 2. Okay. Next question. Next question. F of x equal to minus of x minus 1 whole square plus 10. Nothing but f of x equal to 10 minus x minus 1 whole square. 10 minus x minus 1 whole square. F of x equal to 10 minus x minus 1 whole square. Okay. Now, for this function, well, this is, if you observe, this is a downward parabola. Downward parabola. Okay. Downward parabola means maximum exists, minimum does not exist. Okay. Now, how to say this one? Here, what is the given function? 10 minus x minus 1 whole square. X minus 1 whole square is always greater than or equal to 0. Square of a number is always greater than or equal to 0. So, x minus 1 whole square is always greater than or equal to 0. So, as x minus 1 whole square is always greater than or equal to 0, if you multiply minus on both sides, so what we get? Minus of x minus 1 whole square is always less than or equal to 0. Okay. Minus of x minus 1 whole square is always less than or equal to 0. If you add a 10 on both sides, 10 minus x minus 1 whole square is always less than or equal to 10. Okay. Therefore, f of x equal to 10 minus x minus 1 whole square is always less than or equal to 10. Okay. For every real number. So, this function has maximum value. What is the maximum value? 10. At what point when this part is 0? No? When x minus 1 whole square is 0, we get maximum value. Okay. X minus 1 whole square 0 means x minus 1 equal to 0. So, maximum value of f is attained when x minus 1 equal to 0. So, x minus 1 equal to 0 means x equal to 1. So, when x equal to 1, f of 1 is how much? 10. Okay. So, for any value of x, for any real value of x, f of x is less than or equal to 10. So, maximum value exists for this function. That maximum value is 10, and maximum value exists at x is equal to 1. Okay. Point of maxima is x is equal to 1, and maximum value is how much? 10. Okay. As it is a downward parabola, f does not have a particular minimum value. Okay. Here vertex of the parabola, this is a downward parabola. Vertex of the parabola is what? 1 comma 10. So, maximum exists at x is equal to 1, and maximum value is 10. Minimum does not exist. Minimum value does not exist. As x approaches to infinity, now if you observe here, as x approaches to infinity, x minus 1 is also approaches to infinity. So, its square is also approaches to infinity. Okay. Approaches to infinity multiplied by minus approaches to minus infinity. So, approaches to minus infinity plus 10 is what? Approaches to minus infinity. So, as x value increases or x value decreases, as x value approaches to infinity or x value approaches to minus infinity, in both the cases f of x approaches to minus infinity. So, there is no particular minimum value. There is no particular minimum value. So, maximum exists at x is equal to 1, and maximum value is 10. Okay. Now, for upward parabola, minimum exists. For downward parabola, maximum exists. Okay. Next question. F of x equal to x cube plus 1. F of x equal to x cube plus 1. As f of x equal to x cube plus 1. So, for minimum or maximum, here this is there is no minimum and maximum. You know already x cube graph. For x cube it is a strictly increasing function. So, x cube plus 1 is also strictly increasing function. Okay. So, in a interval, in a particular interval you can write minimum or maximum, but there is no interval given. So, for real numbers it is a strictly increasing function. So, no minimum, no maximum. No minimum and no maximum. Okay. Now, for this I will write f of x equal to x cube plus 1. So, f dash of x cube plus 1 derivative is what? 3x square. So, if we equate f dash of x equal to 0, so 3x square equal to 0 means x equal to 0. X equal to 0. Now, f double dash of x equal to what? 3x square derivative is 6x. Okay. Now, f double dash of 0 is what? 0. Okay. Now, here when f double dash of x equal to 0 means second derivative test fails. No. when f double dash of x equal to 0 at a point where f dash of x equal to 0, second derivative test fails, then f of x has neither maxima nor minima at x is equal to 0. Actually that is a point of inflection. That is a point of inflection. So f of x equal to x cube plus 1 has neither maxima nor minima. Okay. So how we can write f of x is x cube plus 1, f dash of x equal to 3x square, f double dash of x equal to 6x. For minima or maximum what will do? First equate first derivative equal to 0. So 3x square equal to 0. So x equal to 0. So at x equal to 0 you have to check sign of f double dash of x. Okay. Suppose f double dash of x is positive at a point where f dash of x equal to is 0. In such case minimum exists at that point. Suppose f double dash of x is negative at a point where f dash of x equal to 0, at that point maximum exists. Okay. Suppose f double dash of x equal to 0 at a point where f dash of x equal to 0, then that point is neither minima nor maxima. That is point of inflection. Okay. It is a point of inflection in this case. Okay. Next question.